Hi, this is Professor Stugard, and in this video we're going to discuss what is machine learning and how is that different from AI. So our goals for this video, first of all, we want to understand how machine learning and AI actually do complement each other, but we want to also make sure we understand how they are distinct. And then we're also going to make sure we learn the basic process of teaching a machine how to learn. So, first of all, AI, or artificial intelligence, is pretty much everywhere right now in our society. Almost everybody is familiar with some sort of AI, either ChatGPT or Siri or Gemini. And most web browsers now, when you do a search, they're going to actually implement and include AI results every single time. Now, we define AI, or artificial intelligence, as a machine learning model that can also act upon requests and communicate easily with people because of an ability to use language. And this is usually referred to as natural language processing, or NLP. So we have three different acronyms: AI for artificial intelligence, ML for machine learning, and NLP for natural language processing. So when it comes to thinking and learning, we typically think in terms of, well, humans are going to learn from experience. And whether that experience is you touched the stove and it was hot, so you don't touch hot things, and we learn that way, or even skills like, let's say, shooting free throws for basketball, you get better each time you do it, right? You're not going to get better unless you actually practice that skill. That's a form of experience, and we learn through experience. That's just the human condition. Now, machines, we typically think of them as following set instructions, like computer programming. And even machines that we don't necessarily think about the computer aspect, but like our washing machines, when we put our clothes in the washing machine and our soap, then the washing machine is following a very specific set of instructions. It is first filling it with water, then it is swirling it around and cleaning the clothes, then it has to drain, then it has to refill with water to get the soap out, and then drain, and then spin again to try to dry it out as much as it can before it gets in the dryer. But again, it's following a very set of steps. And we can obviously tweak that depending on, laundry type or amount of water, that other, whatever else is there. But again, machines, typically, we usually think of them as following a specific set of instructions. Now, machine learning is where we kind of combine those two ideas. Machine learning is when humans are going to program our machines to be able to learn from experience. Or in the case of a machine, it's going to have to learn from data. Right? Machine's not going to experience the world in the same way that humans do with our five senses or six senses. I don't know. It has to learn from data. Now, when I say the word learn, okay, what I really mean is that this machine is going to find patterns in our data, and then from those patterns, it's going to be able to make predictions with the ability to hopefully be able to make better predictions if I can give it more data. But it'll be able to do that without any additional instructions or help from humans. Once we build our model, we can improve it and tweak it, but at the end of the day, it's making those predictions without any human interaction. So, AI, we have this big overarching AI, artificial intelligence, where, again, it can easily act upon our requests. And again, if you've ever used ChatGPT, you can ask it a question, maybe take a few seconds to think, and then it'll type up a reply for you. And again, it acts upon those requests as kind of an intelligent way. Now, inside that, foundationally, is a machine learning model. It is a gigantic neural network that has been trained extensively, and the whole point is that with machine learning, now it can make those decisions without a human being present, right? So, you're the human asking the question, but you type your question in, and then because it can process language, because it has a natural language processing component to it, it can take that request, process it, throw it into our machine learning model, which is going to then output basically just a bunch of predictions about what word should come next. And again, using its natural language processing will produce a result that actually sounds reasonable for most scenarios. Now, when we create that machine learning model, which is what I want to focus on now, we're generally looking to complete two tasks. first, I need to be able to find patterns in my data. And machine learning allows these patterns to be found in data that otherwise couldn't be found by humans. So raw data is messy. It is very, very messy. And it is very difficult in this day and age with the amount of data that exists for humans to make sense of it. I suppose I could sit there by hand and try to, plot ordered pairs on a piece of graph paper and hopefully figure it out. But yeah, that's really not how anybody is doing statistics anymore. We are using technology to make sense of our raw data. And so, again, that first step is to find the patterns. We can input a spreadsheet of data, basically, and the machine can find those patterns for us, which is pretty important when we think about our human kind of experience and the fact that we're looking for cause and effect in almost everything that exists around us. But then that second step is that it needs to be able to make predictions. If it can take that data, find those patterns, and then hopefully in some mathematical way create a model that we can then plug in new data, and it's going to make predictions about that data based upon everything that came before, that's really, really useful for humans. So it's going to be able to make those predictions, again, without another human being present. So there's lots of different ways that machine learning is used in the world around us to make those predictions. And a very short list of examples would be, for example, classifying an email as spam or not. So every single time you get an email, some computer model is reading that entire email before you ever even see it. It reads the email, and based on the words in that email, it's going to determine whether it sends it to your junk folder or to your inbox. And that's machine learning. There was no human involved. A machine read your email and determined which part of your email it should be sent to. Also, forecasting the weather. So again, we have the weather forecasters on there who explain, but again, if you listen, they're often talking about the model that they're using to predict the weather far out. Now, this is a place where that machine learning model is usually also used in tandem with a human being, with a meteorologist who has experience in the field. And together, the two of them, the machine learning model combined with the human being, come together to create our predictions about the weather, right? It can forecast the weather. They'll guess what the weather is going to be like 3 days from now. Also, a lot of times this is another skill where we have kind of delegated it to the machines, determining the probability that someone's going to default on a loan. So at some point in your life, you're probably going to want to take out a mortgage, or maybe you want to get a small business loan because you have a great idea for a new business. Well, these days, it's no longer determined by a human being whether or not you're going to get that loan. A human being might be there to tell you the results, but realistically, this is one that we have delegated now to the machines. The machines are going to plug in all the information. That machine is going to determine whether or not you are likely to default, and then that machine will determine whether or not you are going to get that loan that you so desperately want. But a person's going to tell you, because you're going to take that news a lot better from a person than a machine. Probably, for now. I don't know. But we've definitely delegated that one. Also, one of the things that we have delegated as well to machines is choosing what new TV shows or music you might like. So Netflix, Spotify, all of these entertainment companies are using all of your previous likes, everything that you've listened to or watched before, and trying to build a prediction of what you're going to like after. And again, there's no human involved. Netflix is making that decision. It's not that there's some person at Netflix who goes, he watched show A and B and C, so he's definitely going to want show D over here. No, it's all done by a machine. Now again, you still hopefully have your friends out there to recommend new music or new TV shows to you as well. But again, for these different apps that we use, it's all been delegated to machines. Similarly, every single time that you try to make a purchase with your credit card, typically it is going to be determined by a machine first whether or not that purchase is going to go through. In fact, credit card fraud and banks are huge implementers of machine learning, and they're making these decisions about whether your transaction is a fraud based upon different variables like the location of the purchase, the size of the purchase, aka the dollar amount, what the purchase is for, and comparing that against all your previous purchases that you have made. If a red flag pops up, a machine will tell your credit card, hey, This is fraud before any person ever sees it, which is also pretty cool. Another place that we have seen a huge increase in machine learning is in the medical field. So we have been training AIs now to go ahead and look at medical imaging like an X-ray, and then the AI is going to determine, well, is this a malignant growth or benign, or it's going to help make those decisions. Now, again, typically you have an expert like a doctor who is working in tandem with these machine learning systems. And again, that's really the case in a lot of these places, is that the AI or the machine learning is just this really great tool that helps the human, and together they can do more than either one of them would be able to do alone. But it is a very, very cool thing as we see different industries pick up that, hey, this is where we're at right now. Everyone is using machine learning for something. Now, that machine learning process, how do I actually teach a machine to learn? How can I teach a machine through experience? Well, first, we need to have a question that we want to ask, and then gather data about that. And that's really important. We should be asking questions about things. We should be curious about the world around us. We should have questions about how things work, what we can determine, what we can figure out, and then hopefully we know how to gather data that hopefully will help us find those patterns that we want. Because once we have our question, we have our data, we're going to apply that algorithm to find or describe those patterns for us. And then once we have that algorithm and it has our patterns, well, we can tune it. We can make little changes to the parameters of our algorithm to hopefully make it more accurate and improve those predictions. And then once we have one that we're pretty satisfied with, that it's making predictions that we back and we think it's doing a good job, then we can actually do that last step. We can deploy this tuned machine learning model out into the real world, and it can start interacting and answering questions without any other human interaction. So, even though I listed out those steps, it's also important to recognize that this is not a very linear process. It can be kind of messy, and it can always have places where we want to go back and change things, because sometimes our original question turns out to not be as interesting as we originally thought, right? As I explore my data, I come up with a better question that I want to answer. And then also with that data, we need to make sure that it's complete. Sometimes data is missing. Sometimes it's biased. Sometimes data is just entered incorrectly for whatever reason. Hopefully with exploring the data, we figure that out as we run our prediction models. And as we see and we test to see whether or not it's actually working, sometimes it comes back to, hey, that data was flawed from the get-go, and you are never going to get a reliable model based on bad data. Also, there are many, many different machine learning algorithms out there. One of the most important skills you can learn is to determine which algorithm is actually going to be the most appropriate one for the particular problem you're trying to solve. And the one you choose first might not be the best one. So you have to be open to choosing different types of models to see what's actually going to work. And experience helps, but sometimes just playing around and having fun with this is going to be your best friend. And then lastly, that optimizing that model, that tuning, that making your model a little bit better by slightly adjusting different parts of the algorithm, different parts of the model, those sorts of things. And it could take many different iterations to create that effective model. So, like I said, there's many different choices to be made during the development of your model. The first we typically refer to as representation. When you're choosing which algorithm you actually want to use, we call that representation. Then, once we train our model, then we want to evaluate it. And this is the evaluation stage. This is how I determine whether or not my algorithm was successful at building my model. And then lastly is the optimization. How do I actually go ahead and improve this algorithm? How do I make those changes? How do I tune it? How do I get it to make better predictions for me? So, kind of to recap here. How do machines learn? Well, we have our data set, and hopefully we have our question. From there, we have a bunch of different algorithms that we could possibly choose. So, representation means we choose one of those algorithms. All right? All the other algorithms, maybe we'll come back, maybe we'll use them, but we choose one algorithm to start. We take that algorithm, we apply the algorithm to the data, so data plus algorithm equals our model. And now we have our model. Our model should have all of those descriptions of the patterns we were looking for embedded inside of it so that we can use it for predictions. But once we have our model, we want to actually evaluate how successful it is, right? If I give it some data it's never seen before, right? If I test it on some testing data it's never seen, so it's been trained on some data, I set aside some testing data too so I can test it to see if it's any good. How successful is it? Well, once I know how successful it is, then I want to optimize it. Can I improve it and tune it? And then we repeat this process. So I evaluate, I optimize, and I go back. How did it work? And we run through this process several times, hopefully until we get a very successful model that can make very accurate predictions. Although, like I said, sometimes you can't make predictions. Sometimes the data is wrong. And again, these are all things you kind of want to keep in mind as you keep building these and you're like, wait, why is it not working? But that's the process. Now, just some general tips and tricks to be successful in machine learning. Number one, always try to understand the problem you want to solve, right? Can you be precise? Can you describe it precisely? Because that's part of also thinking about data and how it can be represented. You're going to explore the data first. Before you try to create a model or choose an algorithm, understand that data. Do some exploratory data analysis, right? Do some EDA. How can I represent that data? How can I visualize it? Can I make graphs? Can I try to understand as much as possible before I try to determine what algorithm to use? Because knowing that will then help you choose from that wide variety of algorithms that there are out there. And then you got to kind of embrace that joy of problem solving. You're going to get a lot of things wrong. That's okay. You're also going to get a lot of things right, and it's going to be a lot of fun. So play around with it. Embrace the fact that you're going to be wrong a whole lot. Embrace the fact that it's going to not be great at first, but if you keep working at it and you keep iterating through that process, it'll get better and better and better. And at the end of it, you'll be so proud of yourself for the things you've been able to create. And that also means you got to be willing to try new things when you're stuck. If you tried an algorithm and it didn't work and you're not getting good results, okay, that's fine. Move on. Try something new. Be willing to move on when you're stuck. Now, we talked about just a small part today. We have that AI, kind of that purple circle, which is composed of machine learning and natural language processing. But there's a huge, huge field out there about data. There's data mining, right? How do I get that good data? I need to be able to get that data. And then that data is going to be stored in databases. So I better know how to use databases. And then there's the KDD, knowledge discovery and databases, which is part of data science. So yeah, we better be able to use SQL, which is usually how those are together. And then obviously we're applying statistical methods, so I better know statistics. And that statistics is really related to that pattern recognition, which is all part of machine learning and AI. And then there's that whole other field, the neurocomputing, where, okay, how can I make a machine learn like a human being? Or can I replicate human intelligence with a machine? What about human consciousness? Can we replicate that with a machine? And that's a whole other field that's using all of these same tools to ask and study some really fascinating questions about, I don't know, what it means to be human maybe, or what it means to be a machine. I don't know. I found all this fascinating, and I hope you do too. And there's so many different avenues that you can explore and try to specialize in. And again, just have fun. Whatever you see that you like, embrace it. Jump in. The best way to know whether or not something is for you is to go all in. Give it your all. Give it your best. That is my number one piece of advice for everything in this world. Give it your all. Give it your best. You either find out that you like it, you enjoy it, or you find it satisfying, or you'll find out that you don't, and you can move on and try something new. But unless you actually give it your best effort every single time, you might find yourself going half-assed through something you don't really like for far too long. All right, but let's wrap up this video, which is actually about machine learning and artificial intelligence. Now, obviously we saw that there's a big overlap between machine learning and artificial intelligence. They're both using algorithms, we're building models, we're trying to make predictions. Just remember that AI is also going to include some natural language processing, that NLP. It's also going to require an ability to access information very quickly, right? That can we use ChatGPT or Siri? If it takes 20 minutes for you to get your answer back, you're bored by then. So it's got to be able to use the information quickly too. It's got to make conclusions for you. It's got to actually have a usable product at the end. And it's got to be able to act upon your requests as a human being. It needs to be able to breach that gap between a computer scientist who can use models and program to a lay person, right? Just a regular human being asking questions. All right, so at the end of this video, can you answer these following questions? First of all, most important, what was that process for creating machine learning models? Number two, what do you need to be successful in these fields? If you want to be someone who studies machine learning or data science or even mathematics or programming in general, what do you need to be successful? And then lastly, we're going to use a lot of acronyms because everybody loves acronyms for whatever reason. So make sure that anytime someone says ML, you know what that means. AI, you know what that means. And NLP. All right. Well, that does it for this video. I hope we learned something and I hope we had fun. And as always, please, please, please take care of yourselves.